I almost forget to record. Okay, I don't know what the electronegativity is, but because of the position of the periodic table, I can just tell you that chlorine is more electronegative than hydrogen. Therefore, it's going to have the negative charge. And in any case, if you need to balance it, it's going to be the same idea. In the end, you need this to be 0. And for HCl to be to have a balance, to be electrically neutral, what you have to do is, well, if you already have 1 from hydrogen, then chlorine must be -1, okay? Now here for hydrogen, 1 and 2 makes 2 hydrogens, so sulfur needs to be how much?
-2.
-2, okay? Potassium, the rule for potassium is group 1, so it's going to be 1. Therefore, chlorine is going to be -1, okay? It needs to be balanced. Okay, here. This chlorine from here, because it's a binary compound, this anion, we call it as chloride, okay? Now, when we have chloride, the charge is going to be -1. Therefore, here you're going to have -2. So manganese has to be 2, okay, for have the good charge. But you can do it in a different way, okay? You can see the charge, the subscript that is here. You know this one is coming from the element on the left, and you can actually tell that the 2 is actually the charge of manganese. You can do it in both ways. Now I prefer the first way, okay? I prefer to identify chloride ion because I know it's going to be -1. So I know that manganese to be balanced needs to be 2, okay? So I have my equation with all of its charges over there, Belén.
Miss, but chloride is not ClO2.
That's chloride. This is chloride ion, the binary one. Let me show you the difference. Wait. Okay, okay. So you have, when you have just Cl, if you just have Cl is a part of the anions, okay, that Cl is going to be -1. If you have ClO, that's hypochlorite. Anyway, the charge is -1 as well. If you have ClO2, that is chloride and chloride. Remember that when we have binary compounds, they all going to end in IDE, and that is because of the cation that the anion that we are using. All the anions for binary compounds are going to end in IDE. In Spanish, cloruro, clorito, cloruro, clorito, hipoclorito. Okay, so there's a slight difference in English, but a big difference when you pronounce it in Spanish. So cloruro refers to the binary one, so it's going to be just Cl with a charge of -1. And chloride, that one has oxygen, and it is a polyatomic ion, which has a charge of -1, the entire ion. But in this case, we're just talking about chloride ion, because the name of this compound is manganese 2 chloride. Now we need to identify the redox. Which element is reduced?
Manganese.
Guys? Manganese, okay. So for manganese, I'm gonna do my red part, okay? And I know that just because this is the reduction part, I'm going to have electrons in the reactants. Okay? If you want to write it in the left, just to remember the position where to write the electron, that's better. Okay? Now, what element is oxidized? What
Sulfur.
Sulfur. That is correct. Sulfur was here with a charge of -2, and after the reaction takes place is 0. So in the number line, remember in math, we have a number line, okay? So this is 0, -2, -1, okay? So sulfur was here,
Yes.
okay? This was my initial sulfur. And after the reaction took place, sulfur ended up here. So it moved 2 spots to the right, okay? And when you move to the right in the number line, it's a positive action, okay? You are gaining, okay? So your oxidation number has increased. Angie.
Why in the reduced part is from 7 to 2 if it's there is reduced?
Just because a reduction occurs when the oxidation number is reduced, okay? Remember this part. When the oxidation number decreases, we have reduction. But manganese is going to be the oxidizing agent, which is different, okay? So we have reduction here because it was 7 and after it was 2. So the oxidation number was decreased. Therefore, that is reduction. And in this part, in sulfur, as you know, in sulfur, we have the oxidation because it was a negative number and then it ended up as a 0. So it gained, okay? The oxidation number was increased. So here we have the ox part, and in the ox part, we're going to have the electrons in the product. Okay.
It's because in the class we make an exercise that was from N5 and N4 it was reduced because we first have 5 and then in the product we have 4. So it's like don't have logic that
But that is like the difference of the electrons when we calculate the electron part. But this, we're just seeing what happened with the oxidation state. It was negative, now it's 0, okay? So that's why I taught you with the number line. You have your 0 here, okay? In the number line, math, okay? So you have -1, -2. Your sulfur was here. Initially, your sulfur was here, and after, the sulfur was over there. So in math, in the number line, when you move to the right, you are increasing, right? So what happened with the oxidation state? It was -2, and it ended up at 0. So it was increased by 2 spots, 1, 2 spots, okay? So that is an increase in oxidation number. It's like you had a debt and now you don't have it, okay? That means that you don't have negative numbers in your financial numbers are not going to be negative anymore, more or less like that. So after this, we are going to write the half reactions, okay? The reduction part that is in with manganese, okay? We have manganese with a charge of 7, and we have manganese with a charge of 2. Okay? So, okay. This is not the case. And I don't like to say it like that because I know that sometimes I tend to be confusing when I mention things that are not happening in the reaction, okay? But imagine, just imagine, pretend that I have Mn2. What would we have to do? We would have to balance this half reaction. So there's a part of the steps that says balance if needed. So in here, if you will need to balance this manganese, you have to put a 2 in front. This is not the case, okay? Because we have just one manganese in each side of the reaction. So now we need to see the difference of the electrons, okay? You had 7 electrons first, and after the reaction took place, you have 2. The difference in the electrons is how many electrons?
5.
5.
5 electrons, okay? So the difference is 5. So those 5 electrons, you're going to put them in the reactants, okay? So you will say manganese plus 5 electrons, the difference between 7 and 2. Now in the oxidation part, the oxidation is between sulfur, okay? So we had sulfur with a charge of -2, and after the reaction, we have the sulfur with a charge of 0, okay? So the oxidation number was -2, and after was 0. The difference between the two numbers is 2. So in oxidation, we're going to include those, okay, those electrons in the products. So we're going to add the electrons in the products, okay? And now, what do I do after? I need my electrons to be the same. In this case, they're not the same. And remember that in chemistry, it's not like I'm going to multiply times 2.5 because 2.5 as a coefficient doesn't look right, okay? So we're going to use whole numbers. So there's no way that I can multiply 2 with a whole number and get 5. So what I'm going to do is I will cross multiply. In other words, I'm going to multiply times 2 because of that 2 that is below, and times 5 because of the 5 electrons are above, okay? I'm going to cross multiply. To have the, remember the purpose of this is to have the exact number of electrons. Once I do this, I'm going to have my redox one more time. So in reduction, let's work with the half reaction of reduction again. That I'm multiplying times 2. So I'm going to apply distributive property. 2 times this, 2 times that, 2 times this, okay? Belén.
Miss, isn't it supposed to be 2 in the products, in the second one, subtracting so that we can cancel after, like positive and negative?
Uh-huh.
Well, it's adding.
Yeah, I know your point because I know that I wrote loses electrons and gains electrons, but in the end, it's like the example that I told you the other day. When you have an equation in math, okay? When you have an equation in math, just think of this about like a normal equation, okay? So imagine that you have y plus 3 equals to x plus 3 plus C, for example. And I say, okay, guys, well, 2C to make it more complex. Okay, okay guys, I say, I want you to isolate Y. Okay, so I can think of this like both plus 3, they're doing the exact same operation in both sides of the equation, so I can cancel. Or I can see y is equal to x plus 3 plus 2z minus 3 from the other side. In the end, they're both going to get canceled. So they are canceled, my friend, because one is in the reactants part and the other is in the products part. Imagine that this arrow is like an equal sign, okay? If I put these electrons in the other side, once they are multiplied, I mean, is if I send it to the other side, they're going to be canceling anyway. So don't focus on that part only, okay? Because in the end, they're going to be canceled because of they are doing the same operation in both sides of the reaction. We apply distributive property and we multiply each part of the reaction, the half reactions. Remember, this is the method that we know as half reaction. Okay, I didn't even know how to write. Anyway, so you multiply every number. So 2 times manganese give us 2 manganese. 5 and 2 makes 10 electrons. And then 2 times manganese gives me 2 manganeses with a charge of 2. Okay. In the oxidation part, I'm going to have 5 times sulfur. So I'm going to have 5 sulfur with a charge of -2. After the reaction, I'm going to have 5 in sulfur, which is 5 sulfur, but this one with a charge of 0. And I'm going to have 2 and 5, that makes 10 electrons. Now I'm going to add them all. So I'm going to have 2 manganese plus 5 sulfur, okay, plus 10 electrons, producing 2 manganese plus 5 sulfur plus 10 electrons. You can cancel the electrons from here, so you can skip that part, or you can do it over here. It doesn't matter, okay? In the end, it's the same result. So what is going to be your result? 2 manganese and 5 sulfur, producing 2 manganese and 5 sulfur. Now, this gives me the coefficients, okay? These coefficients, I'm gonna use them in the main equation. So I'm going to write the main equation one more time. Okay, and in the part where I have manganese, I will put the 2. Okay, here I have manganese, so I'm going to put the 2 as a coefficient. Okay, in the part where I have sulfur, I will put the 5. Okay, then in the other side where I have manganese, it's gonna be 2, and where I have sulfur, it's gonna be 5. And from this, now I'm going to do a final check. If I need to make some adjustment, it's gonna be a very simple adjustment. Okay, so I will list all my elements from metals: potassium, manganese, and then my non-metals: sulfur, chlorine, and then hydrogen and oxygen. And I compare what I have in both sides. I have 2 potassium over here, 1 potassium over there. 2 manganese, 2 manganese. I have 5 sulfur and I have 5 sulfur. I have 1 chlorine and here I have 4 chlorine. Here I have 10 hydrogens, no, 11 hydrogens. I have 11 hydrogens and in the other side I have just 2. And in oxygen I have 8. Yeah, just 8. And in the products I have just 1. So still not balanced, but we already found the most difficult coefficients that are the ones when we are balancing. These are the 2 most difficult coefficients to find. So what do we need to do? We're gonna make just a little adjustments. So for example, I'm going to start with potassium, okay? Potassium is 1 in this side and I want it to be 2, so I place 2. My potassium is 2 now, okay? But this changes my chlorine. Now I have 2 plus 4. I have 6 chlorine. I had 5 chlorine before. I didn't notice until now. Okay. Now, to balance chlorine in the other side, I need to place 6 in front. Okay. So I have 6 chlorine and hydrogen is going to be 10 plus 6, 16 hydrogens. And in the other side, to balance 16 hydrogen, I need to multiply hydrogen 2 times 8. So I have 18. And that also changes my oxygen into 8. And with this, we say the reaction is balanced. Emma, I know that you raised your hand.
I was about the chlorine.
I was thinking about it. Okay, when I noticed the chlorine, I was maybe that's why she raised her hand. In the end, you can see you can drag some mistakes, but in the end, if you do the correct process of the correct balancing process, it's gonna be fine. Okay. Why? Yes, I put 18, it's true, but it's 16, okay, 16. I'm dumb, that's the reason. There's no other reason, but it's balanced, okay? That's the most important thing, that is balanced. 8 and 2, 16. Ah, yes, it's that I'm dumb. I was thinking about the oxygen, most likely.